boiling, it has reached a staggering temperature of approximately 1,800 to 2,200 degrees Fahrenheit, 982 to 1, 204 degrees Celsius. At this extreme heat, the steel becomes pliable, entering a plastic state that allows the blacksmiths to manipulate its shape without risking structural damage like cracking or brittleness. The billet is firmly gripped with precision by a skilled worker using long, sturdy tongs. The worker's hands are protected by thick industrial-grade leather gloves designed to withstand intense heat and prevent burns from sparks or accidental contact. The control grip ensures the metal is positioned exactly beneath the massive power hammer, a machine engineered for relentless repetition and immense force. This hammer, weighing several thousand pounds, can deliver impacts upwards of 20,000 pounds force, a testament to the sheer power necessary for shaping solid steel. The power hammer's rugged cast iron frame, painted black to resist corrosion, stands as a symbol of industrial durability. Beneath it, the hardened steel anvil absorbs the rapid-fire blows, providing a stable surface to shape the glowing billet. The rhythmic pounding echoes throughout the workshop, a powerful soundtrack to the transformation of raw metal into a precisely forged component. The environment surrounding the workers is rugged and utilitarian. The dirt and concrete floor bear the marks of continuous labor, scattered with metal scraps and tools. Industrial ventilation fans hum in the background, circulating approximately 3,000 cubic feet of air per minute to mitigate the heat generated by the furnace and molten metal, maintaining safer conditions despite the extreme temperatures. The teamwork on display is as vital as the machinery itself. The main blacksmith demonstrates a combination of brute strength, acute focus, and years of experience. His posture reveals the tension between control and power, ensuring each strike brings the billet closer to its intended goal. Nearby, colleagues stand alert, ready to intervene with tongs or apply a fresh load of metal to the floor. This synchronized dance between human and machine is both a spectacle and an art form. Hot forging, a process depicted here, is invaluable for producing parts with superior mechanical properties. By heating the steel to its plastic state and hammering it repeatedly, the grain structure refines, eliminating internal defects and increasing tensile strength, toughness, and resistance to fatigue. These qualities are essential in manufacturing parts destined for demanding applications from construction machinery like excavators to agricultural equipment and heavy-duty automotive components. The presence of heavy equipment, such as a Komatsu excavator visible in the background, reinforces the connection between the workshop and industry, requiring robust forged parts. Every meticulously shaped billet here might become a critical link in a hydraulic arm, a sturdy axle, or a reinforced frame, vital for ensuring the safety and efficiency of machines operating under extreme stress. Ambient conditions in the shop add another layer of challenge. Noise levels soar beyond 90 decibels, requiring protective hearing equipment. The intense heat radiating from the forge and the glowing metal demands constant vigilance and adherence to safety protocols. Workers wear protective eyewear, heat-resistant gear, and communicate clearly to prevent accidents in this demanding environment. Visually, the scene is striking. The fiery glow of the steel contrasts sharply against the dark tones of the machinery and workshop interior, highlighting the elemental force of fire shaping metal. Dust and sparks catch the light, swirling in the air and adding texture to the atmosphere. The concentrated expressions on the workers' faces convey pride, resilience, and a deep respect for their craft. In sum, this image is a powerful tribute to the timeless relationship between human skill, mechanical innovation, and the raw forces of nature harnessed through industrial forging. It captures the transformation of elemental steel into indispensable components that uphold the machinery and infrastructure fundamental to modern life, all driven by the dedication and expertise of those who master this challenging craft. While the power hammer symbolizes industrial progress, the fundamental principles remain unchanged, harnessing heat and force to transform raw metal into functional, enduring forms. The workflow in this forging shop is carefully orchestrated to maximize efficiency and quality. The heating of steel billets is controlled with precise temperature monitoring, often using infrared thermometers or pyrometers, ensuring the metal reaches the optimal forging range without overheating or compromising its properties. Furnaces may be fueled by natural gas or electricity, depending on the facility's infrastructure and environmental considerations. Once heated, the billet is transferred swiftly to the forging area to prevent heat loss, which would increase the force required to shape the metal and risk defects. The power hammer operator, trained through years of apprenticeship and hands-on experience, synchronizes their movements with assistants responsible for repositioning the metal and maintaining a continuous workflow. This teamwork reduces downtime and maintains consistent product quality. Advancements in forging technology have also introduced computer numerical control (CNC) systems, automating aspects of hammer operation and part handling to enhance precision and repeatability. However, the human element remains indispensable. Skilled operators interpret subtle variations in metal behavior, adjusting their techniques in real time to compensate for inconsistencies in material or environmental factors. In terms of safety, modern forging shops adhere to rigorous standards established by organizations like the Occupational Safety and Health Administration, OSHA, in the United States. Personal protective equipment, PPE, extends beyond gloves and eyewear to include flame-resistant clothing, steel-toe boots, and ear protection. Emergency protocols and safety training are integral parts of daily operations, reflecting a commitment to worker well-being amidst inherently hazardous conditions. Environmentally, forging facilities are increasingly adopting sustainable practices. Energy-efficient furnaces, waste heat recovery systems, and emission control technologies reduce the environmental footprint. The steel used often comes from recycled scrap, underscoring the role of forging in the circular economy. The final products forged in such workshops serve critical functions across a broad spectrum of industries. In construction, forged steel components provide the backbone for cranes, excavators, and other heavy equipment. Automotive and aerospace sectors rely on forged parts for their strength and reliability, vital for safety-critical applications such as engine components and motor gear. Even in consumer goods, forging contributes to producing durable tools and hardware. This is more than a snapshot of human labor. It is a window into the dynamic interplay of history, technology, and human efficiency. It illustrates how centuries-old methods adapt and thrive within modern manufacturing ecosystems, sustaining industries that drive economic growth and societal advancement. The glowing steel billet, shaped by the rhythmic alloys, embodies both the raw power of nature harnessed by technology and the enduring spirit of craftsmanship passed down through generations.